Worksheet 7, question number 1. How can you decide whether a bond is polar or not? If a molecule has polar bonds, does that make the molecule polar? Well, a polar bond is essentially the bond between two atoms with difference in electronegativity. So carbon and oxygen, for example. These are two different molecules that have different electronegativities. So this bond is polar, and we draw the dipole towards it has a dipole that is pointing towards the more electronegative atom. However, if we have carbon and carbon, this is not a polar bond, right? Because these two have the same electronegativity. They are the same atom. This is a non-polar bond. So let's go to the second part of the question. If a molecule has polar bonds, does that make the molecule polar? Well, let's see. In ammonia, we have nitrogen connected to 3 H's with a lone pair. Now the dipoles are pointing towards the nitrogen, right? These dipoles do not cancel out, so there is actually a resultant dipole that's pointing up. So actually this molecule is polar. It has polar bonds, and overall it is a polar molecule. However, how about carbon dioxide? So carbon and oxygen, that's definitely a polar bond, right? However, as you can see, the two dipoles actually cancel each other out. So even though the CO bond is polar, the molecule is nonpolar. So will only be polar if the dipoles don't cancel out. There's a resultant dipole, then it is polar. How about BF3? So the bonds are connected to fluorines, and each bond definitely is definitely polar, right? Because fluorine is very electronegative. So in here, BF3, it has a trigonal planar structure, right? And so the 3 arrows actually all cancel out because they're on the same plane. Therefore, BF3, although it has polar bonds, the boron, the fluorine, that bond is polar. Overall, the molecule is not polar.